Okay. If there's no more questions, then Ross, do you want, I'm sorry, John Michael, do you want to just try to queue up here and see if we can get your screen to work? Because I know Zoom's been acting a little wonky today.
Sure. Yeah, it's never good to hear the message on my screen that says internet unstable right from Zoom. So yeah, it seems like we're okay. I'm gonna show some drives in the video before we hop in over to the sharing.
Sure.
All right, well, some of my colleagues prototyped me some of these new E3. I don't know, Paul mentioned this. This is based off the E3 version 1 spec. So the version 2 spec is now out on SNIA. If you guys go to the SFF section of SNIA website, where the version 2 moves the connector down a little bit and actually increases the length by about 10 millimeters. But you can see here, this is the thin and the thick. There's kind of the 1X and 2X devices. This is 7.5 millimeters, and this is 16.8. But this is kind of the 2U optimized EDSFF form factor. And of course, Jason showed our favorite, the ruler, the E1.L. This is the 18 millimeter that goes into that JBOF compute. And then we have, of course, E1.S, our favorite, which we're going to talk a lot about today. And we have the 9.5 millimeter, which is kind of optimized for a high drive count and max performance scalability. And we have the 15 millimeter, which is kind of the best of both worlds, where you get good performance and power scalability, and you get a good number of drives per server. And I'm going to show some designs for both of these.
Hey, thanks, Joe Michael. For those that are in the audience, you want to scroll down to the bottom of your screen and click the little door to actually enter John Michael's session. And that will also update the media links on the side. So if you wanted to get access to his deck, you could do it during the session. So John Michael, I believe you are on.
Can you see what I'm sharing? That was weird.
We could see it for a second, and now we can see your camera.
Weird. It's giving me a strained. It said my thing wasn't on top, but it seems like the desktop sharing will work, right?
Yep, we can see your.
All right. So we're going to talk about SSD form factors, of course, my favorite EDSFF. So I'm John Michael Hands. I'm a product manager and strategic planner at Intel. I also co-chair the NVMe Express marketing work group and the SNIA SSD special interest group. And so one of the things that we own in that SNIA group is the actual marketing of EDSFF. And so that webpage on SNIA that shows all the EDSFF form factors, we own that, and all the other SNIA SFF specifications as far as EDSFF. If you guys saw, we actually did a really nice webcast with a bunch of the good folks on the phone here, like Jason, Ross, and Paul on EDSFF. That's now on YouTube for on the SNIA YouTube. That's a good intro. I get asked a lot of times, like, what is EDSFF? We want a basic overview for EDSFF. So that's where I send them. And today we're going to talk about cloud storage. Today in the cloud, U.2 and M.2 are used pretty widely. Jason mentioned, that Microsoft uses M.2, and there's other, major cloud service providers in the U.S. That are optimized around 1U chassis that use kind of 2 connector topologies with U.2, just cable connections. There are a bunch of CSPs in PRC in China that actually use 2U platforms as kind of the standard building block for the cloud, and most of those guys use U.2. So they're both used widely today. And I think there's really good opportunity for EDSFF as we move in the next couple of years. And, basically, we showed you guys with the drives, big drive, little drive, and they're really optimized for different segments. And the way we see EDSFF, from Intel, for E1.L, it's really optimized for capacity optimized drive for the best TCO. And we see that as a very good home for QLC drives. And today we have up to 15.36 terabytes on that form factor. And just the large amount of board real estate gives you a better cost as far as developing the drive, as far as not having to use really high NAND stacks for the packages. And it gives you nice thermal performance to be able to actually have this giant piece of aluminum bonded to all the components in the SSD. And then you have the hot pluggability and serviceability that makes it a really good, really good for storage. As Jason mentioned, not a lot of people want to use this outside of high capacity storage. So for a storage optimized use case where you need high capacity, low cost, best TCO, E1.L is good. But for compute use cases or for kind of mainstream form factors, E1.S is really great. And the very easy way to think about this is kind of by capacities. So for smaller capacity SSDs, E1.S is always going to win. And now we're at a point where, you can build an E1.S SSD that has the same performance as a U.2 in a smaller form factor. And so now there's really no excuses. If you're in a 1U server, E1.S will always offer better performance per watt, better performance scaling, so performance per 1U server, and it's just completely optimized for 1U designs. It's really why we call it E1, is the 1 in E1 literally stands for 1U, is optimized for 1U design. And it was built to be serviced in a 1U server. And so this is just right out of the spec. And we mentioned, there are a lot of different options in the spec in the first devices. So Intel has a product called the P4511. That was this 5.9 millimeter, and we have a 4 terabyte drive that we ship today. And yes, we were the first ones to ship an EDSFF drive in the middle of 2019. And I was the product planner for this product, as well as our new Gen 4 and Gen 5 drives that we're working on. And when we designed this product, the other form factors didn't exist. These enclosures and the symmetrical and asymmetrical didn't exist. And since then, when we originally designed E1.S, it was really about how do we make M.2 better? So, hey, you have a higher speed connector that's hot pluggable. You have these mounting holes for standard heat sinks. You have 12.5 watts, versus, the 8 watts at M.2, so you get a kind of increased performance. But as the industry evolved, it really became apparent that, putting an enclosure around these is a smart thing to do. And one, just because it drives up the power, and then you can have better performance, especially when we start looking at, 2 and 4 terabyte drives, and moving from there to 4 and 8 terabyte drives in Gen 4 and Gen 5, you really need the extra power to get scalability for performance and I/O. And the other thing that I think Ross mentioned is, the objective is for a manufacturer to have one PCB design, put 3 different pieces of aluminum. If you actually see here, I can hold up the 9.5 and the 15 millimeter design. They actually use the same rail. Really, the only difference is the fins. And the same with the 25 millimeter. The fins are just longer. And so you can make designs and latches that are all interoperable, especially if you have a 25 millimeter design. It could take a 9.5 or could take a 15. But we expect there to be optimized designs. And I'll walk you guys through where we think that optimization lives. But one is on power and thermal. One is on the amount of I/O density you want in a server. And when you, I'll talk about that here in a few slides with some of the Intel concepts. This is great. I don't have to walk through this slide too much because Ross already presented it, the Yosemite V3. But again, Facebook and Microsoft have done a bunch to push EDSFF into the mainstream. And I've been talking about EDSFF for 3 years because I was the product manager for the original Intel ruler. So we worked very closely after we designed the ruler to go talk to customers. And the biggest feedback we got was, go make this an industry standard. And so it's been a great journey to see that actually go from just kind of a niche, boutique product, which actually won a lot of awards for Intel on design for being kind of revolutionary, and then now to an industry standard product that we actually see in mainstream cloud designs. And Jason mentioned, in the Microsoft use case where you have high density storage. This is that JBOF that takes the 18 millimeter E1.L. E1.L is going to win versus U.2, and it's going to win versus E1.S. You can fit more capacity per drive, and then you can fit more of those drives per 1U server. And the density drives up rack consolidation, which helps for total cost of ownership. It helps you get a higher number of terabytes per watt, which also helps for TCO. And at the end of the day, the way that these cloud storage vendors and cloud service providers actually think about TCO is it's TCO dollars per terabyte effective. So that's after replication, that's after compression, that's after all the overhead of the reliability, and then per rack. So they're looking at that, the total cost of ownership of all the power, all the CapEx, all the servers in the rack, all the other stuff amortized over all that capacity in the rack. So the higher capacity you have, the better the TCO looks. And that is what the E1.L is all about. Now for mainstream designs, again, Jason mentioned where you don't need a ton of drives per server in a standard compute node for a mainstream cloud. You might need 4 to 8. I'm going to talk a little bit about how I surveyed some customers to get some feedback on that. But then this gives you a good amount of scalability no matter how many drives you want to add as far as getting better density, I/O density versus U.2 or other competing form factors. In a 1U form factor, you have to put the U.2 horizontal, and that definitely limits the amount of space you can have. And in a 1U server, a form factor that's literally been designed for a 1U server will always win out in density. And Ross talked quite a bit about the Facebook design, but I think it's really awesome that we have this unique sled and the 4 E1.S's in this Yosemite V3. And so these are the Intel just kind of optimal hardware designs as far as just mainstream designs for rack scalability for E1.S. And so if you look at a 1U server today, and this is standard across many OEMs and the cloud providers, if you want serviceability in a 1U with U.2, you have 10 U.2s in the 1U, and they're put horizontally in a backplane. And typically what exists today is most commonly for most of the servers in production, you have to actually buy a retimer card or PCIe switch card, actually put that in the adding card slot, cable those up to the backplane, with either expensive, OcuLink cables or slim SAS cables or mini SAS HD, and it's a expensive topology. Where moving to this EDSFF type topology, where you have that design where you can either route the CPU lanes directly to the edge connector, like in here we have this orthogonal connector, or you can have this design where there's a couple inches of trace to the edge connector. This is like an OcuLink or slim SAS cable that goes to the backplane, and the backplane can go right to the orthogonal connectors. And this will be a much lower cost design and lower cost attach of NVMe, which will help these high drive count NVMe systems not have a huge burden of cost. The other thing that's really good about E1.S is obviously the performance scaling. So if you look at 10 U.2s versus 32 E1.S 9.5 millimeters, you're at 3.2x the amount of IO density as far as if you're looking to build the highest performance box. And E1.S, as far as U.2, will scale up to a certain capacity point, and that capacity point obviously differs by every vendor because every vendor has slightly different NAND stacks. But with a standard 64 gigabyte die, going up to 4 terabytes is no problem. You can go up to 8 terabytes, in an E1.S, maybe slightly more expensive, but the designs are there today. And now pushing past that, I mentioned, is not a good idea. That's where you want to move to E1.L. But again, when you can fit 4 or 8 terabyte drives and fit 32 of them across the front of a 1U, that's a whole lot of IO and capacity and performance. Now in the E1.S 15 millimeter, this is kind of more of a mainstream design where we have 24 E1.S in a 1U. And again, that's more balanced towards the number of CPU lanes that are going to be routed to each edge connector. And then, these designs will scale from PCIe Gen 4 and also scale out to PCIe Gen 5. And again, this is just to literally show kind of the design points of the drives of how many drives are supposed to be per 1U node. Intel is designed for our cloud programs. We have these custom designs we support for tier 2 and tier 3 CSPs, which are kind of the next big guys after the largest cloud service providers, many of which have talked here in the OCP summit. And this is the design that they mocked up with the E1.S 15 millimeter, and there's 12 of them in a 1U with 2 OCP NICs. And if you saw in the OCP virtual summit in March, Microsoft had the similar design with the secure control module here, and then 4 drives. And you can imagine, anywhere between 4 and 12 drives front serviceable here is going to be really good. Also, the other thing about the OCP NIC is that it actually uses the same connector, just a larger variant with higher number of PCIe lanes. So if you did want to have an easy test, somebody asked about just a easy test. If you have a server that has an OCP NIC slot, I believe that's actually electrically and mechanically compatible. Maybe not so mechanically, but it could work just for a quick test. And for all those IHVs out there, you can make some test slots for us. So I'm going to walk through, earlier this year, I was asked to present our Intel has this thing called the Cloud Board of Advisors, where we basically talk to a bunch of large cloud customers and we get their feedback. And I gave them a survey. I was asked to talk about EDSFF, and we talked about QLC and EDSFF. And I had great feedback on EDSFF and E1.S. So one, as everybody today mentioned, it's happening. I get the question everybody just asked, somebody asked, which was, when is this happening? Well, their Flash Memory Summit is also this week. There's multiple vendors that announced products. You'll see a lot more product announcements in the next year as well, and platform announcements. I know platforms are pretty sparse. There's a couple on that first generation E1.S, I believe like Lenovo and Supermicro and AIC that have announced E1.S capable platforms today. But I'm really excited for lots more hyperscale platforms following the lead of Microsoft and Facebook and OCP. And for Gen 3, 2 and 4 terabytes is kind of the sweet spot. And again, one of the things cloud customers want to do is not give up performance density in that IOPS per terabyte. And so when we move to Gen 4, that's when, okay, maybe 2 and 4 terabytes is still good for a lot of volume, but we want to see if we can, start squeezing 8 terabytes. And for Gen 5, the feedback we got was they really want to double the performance, between a 4 and 8 terabyte drive, to have an 8 terabyte drive that's basically twice the performance of a 4 terabyte drive. And if you can keep this performance scaling and scaling density as far as the form factor, then you just have more flexibility in the designs as far as PCIe lane utilization. I mean, the other thing is that PCIe lane count on CPUs are going up, and there's a lot more ecosystem support for PCIe switches and high performance, PCIe designs. So again, there's just going to be tons of different designs. As we get to Gen 5, there's going to be stuff where there's PCIe Gen 5 by 2 and by 4. But at the end of the day, from the drive side, we still think for E1.S, these smaller capacity drives are really the sweet spot. So I suspect, you're not going to be seeing these like 16 terabyte plus drives in E1.S just because it doesn't make sense. Now, not to say that somebody can't make one, but we really think that the optimal point is these kind of smaller capacity TLC drives that are really optimized around performance scaling for cloud compute. Now, the optimal power, I think customers are trying to keep the drive power low as possible. 20 watts is nice. Better than U.2 is kind of where we want to be. And the tricky part is now scaling that performance, when we get to PCIe Gen 5, without scaling the power. And even if SSD vendors have a 20 to 30%, gen over gen improvement in performance per watt on the NAND, it's going to be really challenging to continue to scale performance up to 8 terabytes without increasing the power. But that's why we designed the form factor the way it is. So, add a nice airflow, E1.S 15 millimeter can dissipate 25 watts or more. Potentially we have, Intel shared some data in the OCP virtual summit in March that suggests with the adequate airflow and inlet temperatures that we could even push the E1.S to 35 watts. So it's very exciting for the form factor to be kind of that perfect sweet spot for performance for PCIe Gen 4 and Gen 5. And this was these out of the survey questions that I had, as far as like the broadest set of responses as far as where they ranged was the number of drives per compute node. And you just saw even from Microsoft and Facebook, it's not 32 drives, it's not 24 drives. For mainstream cloud compute, generally they're not buying that many drives per server. It's just too many. That's more of a storage type node. And the response that I got back was 4 to 8 seems like the right number of drives for kind of the optimal performance matching with the CPU and DRAM density. And with that, again, I'm going to try to keep everything at SNIA up to date. The more stuff we can push to open source as far as open specifications at SNIA, through SFF, through our presentations at YouTube and the SNIA webpage for form factors, the less questions we all get on EDSFF. I know we're trying to make that as easy as possible. As Jason and everybody mentioned, the OCP storage work group is kind of where we're working on all this stuff, and hopefully there'll be a lot more E1.S designs that get contributed very soon. And yeah, we're a huge opportunity for everybody in the industry to kind of innovate around this. And now that we have all the SSD vendors kind of on board with building drives, the next step is really just getting the platforms and getting the ecosystem robust over multiple years of shipping real products. And with that, yeah, again, here's just some links to SNIA, and of course the SNIA SFF page where you can find the latest EDSFF specifications. And then these are the webcasts that we did. If anybody wants an overview of EDSFF and the form factors page. With that, I'll take some questions. I don't have the Chrome page up as fear of it would crash my Zoom. So you'll have to read me the questions.
Yeah, John Michael, there are no questions right now, at least none that I see, but maybe David and maybe David and Jason might have something, or folks on the Zoom call might have questions, comments.
Yeah, let's go to see if there's anybody on the Zoom call, give them preference before Dave and I ask questions.
Hi, John.
No urgent question. Oh, wait, there you go.
Yeah. So one question I have was on the sideband signals. Since if you see the E1.S or the EDSFF 1C and 2C connectors have a lot of sideband signals like power disable and other signals used for hot plugging. How do you see them being used in a storage form factor? users?
Well, I know, yeah, I know something like power disable that wasn't widely used on the U.2, is, being used on EDSFF platforms. At least most customers I've talked to on backplanes have designed it. But yeah, definitely the idea is that the EDSFF drives are going to be front serviceable and hot pluggable. And yeah, the ecosystem for PCIe hot plug is a whole lot more mature than it was when we started doing U.2 hot plug in 2014. There was many challenges, but I think the industry is a lot farther along than we were then.
Jason, I still don't see anything, or David, I don't see anything on
Well,
the.
I will have one for John Michael then. So you showed some top-down views of some proposals, design concepts. I think that's great. I think it lets people see kind of what your team's thinking for different options. Would you guys consider opening up like maybe a step file of that, just very high level, so people can see it in real time? That way they can get a little more sense of what that looks like versus just the top-down view.
Yeah, I would. I can ask the people that render these for me so they're part of our data center group. And again, we have tons of designs going on for the cloud and for the next gen, Intel platforms that we're working on, having EDSFF as kind of a mainstream form factor. And yeah, all I can say, I don't have those in front of me right now, but yeah, I think we'd be happy to, yeah, I think we would be happy to support something like that.
Yeah, and something to think about. I mean, obviously in the back it has your IP and a lot of your CPU. So if you don't want to do that, that's great. But if you were to cut it off kind of where the fans are into the front, I think it really gives people a sense of what this actually looks like in practice. They can see how the connectors are cabled. The cables come into the backplane, and they can see the Facebook and Microsoft designs as we start to release those. But since these are very preliminary, and you have a bunch of different ideas, and it'd be great to see the community with that.
Yeah, specifically around, if you guys are Intel customers, which many of you guys on the phone are or Intel partners, we have something called the Platform Design Guide, which basically has these topologies defined and now includes the EDSFF, loss budget for PCIe Gen 4 and Gen 5 in the future, and it has the trace lengths and the cable lengths and everything that you need to do to design these types of platforms. So yeah, again. If you're Intel, check the Platform Design Guide. We'll work on from the data center group and the cloud platforms group that helped me get these design concepts out. I'm gonna hopefully many of them are listening or on the call from they're presenting other sessions here at the OCP Tech Week, and yeah, they can help. We'd like to start releasing some of these designs, and we're looking at maybe in the future, this general cloud platform that we're going to have that includes something like this, we would like to release into OCP. So.
All right. Do we have any other questions for John Michael?
Hi, John. One more question. How many 25 millimeter thick E1.S do you think can fit into a 1U server? Do you have any? 16. Okay.
Yeah, sorry, Ross is gonna kill me. No, I had it, it just didn't fit on the slide. Yeah, and I think we mentioned that before. Really, there's no right answer. There's going to be uses for 9.5, 15, and 25 millimeter, and all the SSD vendors that you've seen announce products have basically shown a way to do it all in a very flexible way without having to, reinvent the wheel, just having a different piece of aluminum as on the heatsink. So.
All right. Well, thank you, John Michael. Doesn't sound like
Hey, I was going to say, Jason, you might need to do a little song and dance here. I'm trying to track down Jung-Soo and Yusuf for the next session.
Do we know if they're online yet? Because they have a lot to cover, and I'm assuming this will be a very good session.
Yeah, I don't see them on the OCP. Oh, Yusuf is here. Okay. I just admitted him in. I don't know about Jung-Soo. So, but we still have about 6 minutes, right? The next session starts at 3:45.
Correct.
So,
we have a few more minutes.
Yeah. So, I don't know, song and dance.
So we can also open up, we've had a bunch of presentations today. So I mean, if you have any questions on any of the topics, I believe most of the presenters are still on the Zoom call. So it's a great opportunity for some real-time Q&A.
Folks that are on the line, you can hit the join now button and ask your questions live, or you can also post them in the chat. Either way works.
Oh, I think they're both there.
Oh,
Yeah,
looks like
I
one-
see
I
them.
see them. They're muted.
Yes, yes. But unfortunately, for those on the live session that are watching it through the stream, the session doesn't open until 3:45. So
Oh, that's
even
right.
though we may be early, I would
That's
prefer to wait.
Yeah, you're right. Sorry.
Yep. So we could use this time, you know, for more show and tell and more
How about this?
discussion.
I think we have, since we have 6 minutes, one of the questions on the stream from about an hour ago was, is it true that the E3 form factor is changing? So I believe we have several people who are directly involved with the E3 form factor.
It's out. Go to, I'll post the link in the whole thing. You can go to see the SSFF E1.L is version 2.0 and is live at EDSFF today. You can see. And on the webcast for that video, that I'll post the link. Paul Kaler, who's on the phone, of course, and Bill Lynn of Dell actually went over all the new changes in the specification in that YouTube video.
Paul's also on the call. So Paul, if you want to just give a really quick overview live.
Yeah, sure. I think John Michael kind of covered it pretty well. But yeah, it did actually just go get approved. I think it was late last week. So it's now officially a 2.0 spec. The main changes that came in were the registration on a connector. I don't have a sample like John Michael does, so he can actually do the demo much better. But yeah, that connector location has now been moved up. And actually, one of the primary reasons why we did that was in reference to the earlier discussion around OCP NIC using the same connector. It uses the same base connector, the SFF TA1002, and there's an additional tab on it that has a bunch of additional sidebands that are there for OCP NIC. It's typically we call the connectors we use in EDSFF, they're a 4C connector, or sorry, a 1C for a by 4 interface. And the OCP NIC, like John Michael mentioned, it's a by 16, which is the 4C version of the connector. And they actually use a 4C plus, which has all those extra sidebands. By moving the connector to the location that we moved it to in the new 2.0 version, we actually made room so that you could put a standard OCP connector card edge on an EDSFF E3 form factor. So now the room that we created at the bottom of the form factor, you can put that additional tab that's on the 4C plus. And the E3 form factor supports, even the original 1.0 supported a by 4 or by 8 or a by 16 interface card edge. Now it can still support all the way up to a by 16 interface or a 4C connector with that additional 4C plus tab that the OCP NIC has. So we could start to see additional device types coming in where we have a OCP NIC design dropped into an E3 form factor. And that way that'll enable some more OCP NIC devices at the front of a server. There we go, John Michael. Thank you for the demo. And so that's that connector location is moved more towards the middle now. And that tab for the OCP NIC is right where the connector kind of is now. And that also enables another use case where we can go to even higher power profiles in the future, where that tab location for OCP 4C plus could turn into, there's another variation of that same connector that's a 4C HP for high power. And that tab actually enables that connector to supply up to 600 watts of power. We don't think we need to go to 600 watts, but there could be some really interesting use cases in the future for computational storage and some other accelerators that might be using the E3 form factor. And so we eventually in the future might propose a new kind of medium power tab that could go in that same location. So by changing the connector location, we really kind of open it up for a bunch of multiple device types beyond just NVMe SSDs that could use that form factor. And then the other main thing we did was we grew the length a little bit to make it more compatible with E1.S. And that enables you to potentially, if you're got an E1.S design, you can use that same design and drop it into an E3 case. There you go. There you can see that right now, today, the E1 is actually a little bit longer than the E3 because those are the original specs. So we grew the E3 case length so that you can actually put an E1 SSD inside of the E3 case. So the SSD suppliers can design one design, especially for those lower capacity points, you know, up to 4 or 8 terabytes potentially, and they could leverage that same exact design across E1 and E3. So those are kind of all the major changes we made. In this
so this new, this new E3S will be 112.75 millimeters long in the 2.0 spec, and then the E3.L, it will be 142 millimeters, so about that long. And so it's still pretty small. And then the 2T, which is the 2X thickness, is the 16.8 millimeter. Kind of looks like a U.2 with the EDSFF connector, EDSFF TA1002.
Thanks, guys. Appreciate it.
You bet.
All right, we're coming up on the next presentation. So Jungsu and Youssef, if
Yep.
you're ready, we can get